This is multi-tenant Nagios monitoring. And at this time, don't forget there's a question and answer session when we're done. And raise your hand, I'll come around with the microphone and I'll come over to you so we get both sides when we record this for later listening. All right? Dave Williams, ladies and gentlemen.
Thank you very much. You know my name, you know the topic. Like all good presentations, let's start with the agenda. So a bit about me, lovely. A bit about what I consider to be multi-tenant monitoring, why I did it, and the actual physical, then we go on to the physical design of what I've actually created to try and give you a reference model for if you actually ever want to go in this area. Then there's a bit of chat about service catalogue. For my sins, I've been hit repeatedly over the head, almost, with the ITIL service manual, the international standard for how you provide service to people. And then there's some reflection of that in this system. It's not a closed and finished product. There's a lot of future and a bit of blue sky thinking about what we might do, how we might change it, how we might enhance it. So always welcome anybody's input on that. And then down to the questions. My background, I'm UK based. You might have guessed by the accent, or I'm not from these parts. I've been in the business probably longer than most of you have been alive, which is disappointing to me. Mainframe expertise, IBM, Honeywell in the day, Unix, Linux. Been around. At the moment, I work for a French computer manufacturer. Yes, but there are still people out there making computers, and I work for one of them. And I work in mainframe, Unix, HPC mainly. Where my monitoring comes from is, yes, I used to be an OpenView consultant. I've used NetView on IBM mainframes, and I used to install OpenMaster for a living. I got on to Nagios NetSaint right at the beginning. I was one of the first people to port NetSaint onto AIX, and I still am responsible for that occasionally, and then moved on to Nagios. So I've been around a long time. I've used this in a lot of different ways. So why multi-tenant? Organisation I work for is in the business of outsourcing. Well, some of it is. And when we do that, we take on third-party user customer systems. And we need to support them. It's just that simple. We have to support them. We have to provide third line support, patching support, everyday running of their business systems. We don't really want to be standing next to the machine that does this. We really want to have one slow, central, focused team that does this work. And therefore, we need to monitor what's going on. Now, each customer, of course, has different requirements. They all have different levels of security. When you're working in a credit card clearing organization is different to when you're working in a holiday camp, for example. I mean, they both want the same kind of things, but they kind of have different views on security. They've all got different hardware, software, so there's never two things the same. Some guys are Solaris, some guys have got HP, some guys got Unisys, some guys are IBM mainframe. It doesn't really matter. The whole business is about monitoring what they're doing, repairing things, keeping things running. So one support team, they only really need to know about real problems. The last thing you want with a big customer base is for every problem to wake someone up. You just want the real problems. And the other thing is that support teams are both ways up. They get the trouble tumbling down to them from Nagios or Nagios, and they get the customer filing up to them from the help desk. Service desk, I should call it. I should stop calling it help desk, not ITIL standard, sorry. Service desk gives you stuff. So they've got to kind of, all this stuff's hitting them, and they want to be able to control it and rationalize it. And of course, it's got to work. It's got to work all of the time. There's no, oh dear, that I patched that incorrectly, it's down for a few hours. No, it's got to be up all of the time. So not only is it hardware, software choice, it's about process and procedure as well to protect yourself from the unfortunate accident, which is how you describe it if you've actually perpetrated a disaster. So, any customer can have between 2, smallest, 3,000 hosts. So it's kind of a design and architecture that can handle everything, which is quite interesting. And it's in real time. There's no point in telling them the following day a few things that overnight didn't work. You've got to be able to respond immediately. What the customer wants is things like SLA, service level agreement reporting, all the stuff that maybe happens overnight, backups, other batch. If you're in a kind of banking environment, then you do lots of stuff overnight as a batching inspection and try and get stuff out. And of course, each customer has different service level agreements, and each customer's systems have different service level agreements. They're probably not that unhappy if their static internal HR web server goes down. They're absolutely livid if their external facing banking application goes down. It's a kind of, but it's the same customer. So you've got a kind of, and they all want to be told in different ways. Some people want to know the bad news fast. So you have to ring them up and say. Some people just want to know when it's fixed. Some people want a status that says 7:30 in the morning, everything's good, or not. So it's all very different. It's different for everybody. Everybody's got their own conception of what they want. So, in terms of design, what we tried to build was something that was resilient. Now, you'll see some product selections here as we go through, and don't tie yourself too closely to them, but it is a theme going through, which we will discuss. Virtualized platform. Normally, when I'm putting Nagios to bed, I say, please don't run it on a virtual platform, because there are too many things about clock ticks and timing and reliability that give you issues. What we're talking about here is a central monitoring system. So it's not actually doing a lot of monitoring itself, it's just taking information in. So things about it getting clock ticks slightly awry occasionally is not so significant. So virtualized. Intel-based, I could have done it on Power if I'd wanted to. I could have insisted that we put it all on AIX or HPUX. It wouldn't have made any odds to me, it doesn't matter. Using Zen Server, the reason is that second line, where it says inexpensive licensing, you can read 0. So that's fairly inexpensive, actually. So I get a clustered virtual hypervisor with great support for nothing. Now, you can't do a better deal than that. Then you need, for clustering, shared storage. We have 2 clusters, they've got to have common storage. There are lots of ways of doing that. You can do it with expensive arrays, we'll do it with NetApp, do it with EMC, do it with HP if you have to. But then you can do it the networking way with a NAS, and that's happened. It's just, you may have noticed a thing developing here, fairly inexpensive, frankly. But it did give us a couple of other interesting side effects. And then the LAN infrastructure, always plug things in twice, always have 2 separate things to plug in, always have independent power supplies. It's just basic stuff to try and keep your systems up whilst you're doing business. So that's what it looks like. Now, what I'm also doing here is that I'm making the system pretty much software agnostic. I'm not bothering myself about Nagios clustering. I'm not bothering myself about replication of data, how I do file systems that maybe replicate. What I'm doing is I'm putting this a lot further down in the hierarchy and saying, give it to the hardware. Life is too short to configure global file systems. I'd rather just have something else copy it for me, really. So 2 machines, 2 actual in the cluster, something fails, the VM will fire up on the other side. Yay. Shared storage, so the logs are the same. So we're not losing data, logs and everything swap over. Bonded interfaces, 1 to each switch, so if we lose a switch, everything carries on. The idea is to carry on processing at all times. That 365, 7x24 is essential. The other little thing there at the bottom is that I can't remember how many times I have slapped installers who try to put in unmanaged network switches on my systems. A swift cuff to the side of the head is all you need to say, I must know what's happening with that switch, I must know what its throughput is, and I must be able to manage it, please. It's quite nice to be able to record the config somewhere as well, to be honest. So what does it look like? That's huge, actually. That's far too big. That's about 3 systems in one. But the idea is top-of-rack switches, a couple of small servers, shared storage, and there's a tape library in there. Even when I'm replicating data across geographic separation, I'm old-fashioned enough to think that a tape backup might be necessary. I might one day have to get it all back from 2 fires, or I might one day be pursued through the courts for an amount of data that I really need to preserve. And so after this presentation, if you wanted to ask me how much this entire thing cost, please do. You'll be very interested in the answer. This is the recovery side. So now we've got one lovely system, it's got no single point of failure, it's absolutely lovely, and now we just make another one just like it. And we replicate data. So this is just the same thing all over again, except in my case, about 85 miles apart. So that's kind of safe enough, I think, from the proverbial aeroplane coming through. One of my data centers was indeed, I like to say decimated, but more than a tenth of it was destroyed by an explosion in an oil refinery next door. So I'm quite sensitive about this stuff. I like stuff to be a distance away. The storage replicates itself. It's all beautifully linked. There is one other thing, and that's what it looks like. So yeah, it's two things side by side. We can all kind of draw those diagrams. I'm very happy about it. There's one thing you may have noticed, though, that we'll come on to is all those external customers coming in, the two data centers 85 miles apart, how do they get from one to the other when we have the accident? And the answer is carefully, but mainly because we're using a IP provision with BGP. We've got our own ASN. So when we crash horribly, the whole network switches in one go. So everybody gets switched over. And the customer end doesn't see anything. Now, I said right at the beginning that I didn't mind VMs in the center because all the monitoring is being done at the periphery on the customer site. And so this is what we use at the other end. Now, the last couple of years, I've been talking at these conferences about the use of the Raspberry Pi. And I know that that's inspired a few individuals to actually go out and do this sort of thing. And it counts in this. When we're running big systems, we tend to run a little netbook, that's all. And it's gold disc, so that some bigger customers will actually have a spare one on the shelf, and if it goes wrong, we just tell them to take one out and plug the other one in. It allows us to be a bit clever sometimes about customer networks are always different. So you come to someone and say, I want to see your network to see your systems, and they'll say, yes, that would be nice, but they're all in different VLANs. So then we have to configure the VLANs up on the netbook so we can see them all. And that's unique for every customer. It's just different. If the customer's small enough, remember we had that range of 2 to 3,000, then the Raspberry Pi fits in very nicely at the lower end. It does the job. I have no qualms at all about leaving 2 or 3 of those behind on a customer site, because that's what, $45. I think I can afford that. Then this is going to be topical. In the central site, in the software, I'm running Core, not using XI. I'm running Core because I can hack Core, and I do. I'm running MK Live status for the data collection, not NDO. And I'm running Thruck for visualization. So this is all completely open source software doing a complete job. And look what's in the second line. I've been slightly prescient there, maybe, or maybe I've done this before. I've got an enormous log database. I'm using Elasticsearch and Greylog, but hey, if you want to use other things, that's fine. And that's putting everything into MongoDB. Yes, I'm told by the author that that is a party gorilla in a party hat, which is the symbol for Greylog. There you go. We use asterisk. Big thing, well, big thing to us. We, over many, many years of running support organizations, it's come to my notice that people don't respond to their mobile phone or their pager overnight. Okay, they leave the thing face down, another room, downstairs, nothing. They do respond to phone calls on their landline with a voice shouting down them. And that's what we use asterisk for. So we have a problem, we ring people up on their landline and then their mobile, and then we read out to them some pretty horrific messages suggesting that they should pay attention. And we still use SMS text, so we use TAPI interface to our local provider, so we actually text people as well. So it's kind of the lowest common denominator. If I can reach you by landline or text, then I'm doing pretty well. I'll try the email, I'll try the other methods, I'll instant message you, Some people, frankly, I think it'd be easier to get hold of on Twitter. And we'll do that too. But whatever it is, that's the kind of thing that we do. Yeah, the usual suspects line up, NRPE, NSCA. NSCA NG, use next generation. There's a reason for that. We want to issue a wider range of commands than NSCA normally lets you do. So, because we do a lot of things about acknowledging alerts and stuff via email, and we want to push that back up to do acknowledgement of alerts on services. Sometimes we want to schedule downtime, and NSCA NG lets you do that. We do a lot of hacking of email. God, I hate this thing. It's the most unnecessary thing you'd think you'd ever have to do. Sending emails, anybody can send an email, yeah. Well, within reason. Anybody can send an email and say, yippee, it's arrived. What we do is to say, you can send us a response. And if you get it right, we'll acknowledge the problem for you. If you are very clever, put the right thing in the content, we'll do some commands for you. So our on-call guys will get a thing and go, actually reply, if they put whatever at the front of the subject and send it back, we'll acknowledge it. Because they have to have responded. So in terms of responsibility and reaction and process, they must have seen the alert because they've responded to it. Anybody who puts a filter on that just changes the subject and automatically sends it back is in trouble. And there's stuff that they can say, schedule downtime inside the body of the message. So they can say, whatever, I know it's down, schedule downtime, stop telling anybody, don't get the management out of bed, all that sort of stuff from an email, which is kind of nice. But it does mean you've got to do a lot of processing of responses to work out who it relates to. And then you get the really exciting things, which are unsolicited emails. There are a number of monitoring products that will email you an alert. Thank you, HP, for example, Insight, will send you an email saying, you had an ECC retry on a memory stick, so it's getting towards threshold, you ought to do something about it. And it'll send us an email. You won't actually have anything, just enormous message. And we have to work out from that message which Nagios server, host, service, possibly, does that relate to, and push it through. My favorite is Pingdom. Pingdom is a system that tests access to websites from around the world. We have a number of customers who believe that the Chinese business or the Australian business is very, very important. And so they want to know the response time from their website based in the UK or in the US from that location. And so you end up with caching and Akamai and all that sort of stuff going on. But and Pingdom will just send you an email saying, this site's slow, and you have to work out, great, that's a site. I wonder who it belongs to. If, and you really don't want to go here, if the client doesn't have a proper problem recording system, then we'll sling it into our not very proper problem recording system, OTRS. It's a way of just saying, we can track all the faults that they've come in and all the ones that have been raised, and it's a kind of service desk interface if the customer doesn't already have one. In our business, it would be unusual, but not impossible, for the customer not to already be running Remedy or Assist or something. I mean, that's what we interface to. But in case they don't, we've got to stand by. Yeah. That was latest when I did the slides, honest. So, Core 4, NRPE, NSCA, OpenVPN. Now, why is that sitting there? That's sitting there because we have to have some way of each of the customer sites communicating with the center. And we've discussed the fact that security is important to customers, it always is. And so we needed to put up some kind of IPsec VPN connection to do that. Now, an OpenVPN, bless it, talks quite nicely to Cisco IPsec. So we kind of have a dialogue that says, yes, we need a connection. You need to open these two ports. They're the same ones you open for your Cisco IPsec work that you do all the time. Thank you. And then that comes through to our ISAs, and we process it. On the odd occasion, the customer refuses to open the ports for IPsec VPNs, and then he just gets hoisted by his own petard because we VPN through HTTPS. He's not giving us a choice, so we have to. So that's what it looks like. The prime site, the system, lots of little boxes talking. They don't have to go through the internet. We found that the most comfortable way, shall we say. But if we have a private link with them, then the data flows over their IP network, and that's the end of it. Quite straightforward. That's what it really looks like. A bunch of Nagios Core systems, talking to a firewall, talking to a DMZ effectively, talking to another network. A couple of Citrix servers, and you'll see there email, OTRS, LDAP for authentication, and the PABX virtual machine, which is asterisk. Service catalog. Service catalog. What we use is just a kind of subset of service catalog, because a service catalog really kind of has lots of information. In the ITIL standard, it's the name, the description, related service request types. Can you start it? Can you stop it? Can you own it? Who's entitled to access the service? All that sort of stuff. And that's the way you document the service that you provide. What we tend to do is to take that and say, okay, what we mean is it's the list of services with relative importance levels. Who do you want to tell? How long do you want them to be told? Who gets told next for escalation? And then what are the ways we might possibly recover this situation? One of them is, of course, invoke DR is a classic. It's a little box. If it's not working after 10 minutes, invoke the disaster option. That kind of feeds into the SLAs because you can't have a service level agreement against something that you're not agreed to watch. And also the base of your reporting structures. So our view is that if we haven't had the dialogue and we don't know it exists, then we can't be monitoring it. If we do know it exists and we have agreed to monitor it and there's a service level, then we stick within the service level and we try and achieve that. So it's a two-way thing. It's like pulling teeth, this usually, with a customer. Please tell me what's important to you, and I will make sure it happens. Ways of doing it? Do it yourself is the first one that comes to mind, which is the basic spreadsheet. So someone has had a business, around a business, and they worked out that these are their systems, these are the important services. We can usually take that as a basis of generating the service catalog. You end up with a pretty ugly script, and quite honestly, you end up with a very ugly spreadsheet, but it works. The nice thing about doing this, by the way, is we'll get onto using Chef or Puppet, which is the same approach, except you define things more clumsily, I believe, is that this generates your config. So this just throws out a complete Nagios config. That's it. That's all you do. Host groups, services, escalations, contacts, all pushed out by this. So when the customer says, oh, I've just put 10 more servers in, you just make the change to the spreadsheet and regenerate, and you don't think, nothing comes in to upset your process, and nothing comes in to affect the efficiency of your systems, because you know this generates good code, you know what you just put in, everything's good. And if someone extends it, they say something like, I've got a new application that is in port 9101, there's a good one. I need to see if that responds to a web request. Fine. It just goes as another characteristic to say, this service does this, needs this. And then you just generate. Always just generate. It really does remove all those little options, especially when you're in a dynamic environment or you've got tens of 20s, hundreds of customers. They're all saying, oh, I've just done this. Doing it by hand just doesn't work. You've got to have a system. Multi-tenant, don't you just love it? Here we go. Every customer's got a server 01, or he's got an AD, or he's got something called DNS 01. Thank you. Sometimes customers have really nice naming conventions. Sometimes they're obscure beyond belief. If I see one more customer who's actually got his naming convention based around Star Trek characters, I am going to get very, very upset. I believe in this country the expression is going postal, because I will. However, some people put zip codes and stuff embedded in the middle of their names so that they know where the server is, which works great until 3 years down the line, they move the server. However, what this does do is it gives you different Nagios names, because we have to say it's multi-tenant, therefore this machine is owned by a particular customer. This machine might be owned by this particular customer at this particular location. And so inside the Nagios configs, that's going to be the name. Because otherwise, I can't really have too many server 01s. And then when you get an external error generated by Insight, SW Feltz 01, RAID battery backup, you have to know that before you feed that through NSCA into the system, that's not really that name, it's actually customer lock 1. So you end up with some table lookups in strange places, frankly. So you have to do that sort of thing. It's a curse of the multi-tenant, but there's no escape. There is no escape. People will have strange naming conventions. Customers will insist on having more than one site. All sorts of things. And the key with this item is it has to be part of the process. When a customer adds a system or when a customer moves a system, the change control process must help you update that lookup table. Otherwise, you'll just be putting faults in against the wrong systems. And there's nothing a third level support person hates more than being told that something's broken in entirely the wrong machine. The abuse is unbelievable. Well, that could just be me. Right, visualization. By its nature, visualization is a resource-heavy thing. You're playing with pixels, you're moving pixels around, you're changing the color of maybe a thin line of pixels. You're doing it quite a lot. All the customers want their own dashboard. It's like, yes, I want pie charts, I want graphs, I want stacked graphs, whatever. I want speedos, they all want it in different places. So, what I'm intending to do, and I'm testing at the moment, is to move the visualization out to the cloud. I don't want my centralized systems to burn processor power drawing speedos for a customer. Right? I want them to be taking data in and processing alerts and telling me things. So what we'll do is I'll have a portal that says, okay, Mr. Customer, you want to have a dashboard, log on, we spin up an instance, and it fires up a link back to our central system, our HTTPS, and says, here's your link, here's your dashboard. Lovely. Which wins on both accounts. I can scale horizontally. If the customer decides he wants 100 dashboards displayed across a wall, fine, he can have them. Am I paying for that? No, I'm not, because he's paying for the virtual machines. So if he wants 100 images, he pays for 100 images. It's a way of just moving just offloading that piece of work. It's nice, it's very attractive, it just doesn't do anything for the central service. Yes, load sharing. This is the other bugbear. If you use things like check WMI Plus to check Windows services, it's a marvelous thing. It'll check 30,000 plus process counters on a Windows server. It takes a long time of wall clock time. So when you actually run the command, Windows picks it up, thinks about it, does a little check, sees what day of the week it is, sends it back. Which is very nice of it, but it is real wall clock time. You're hanging around while the second hand is moving. This is not millisecond stuff. This is taking a long time. And this can really, really, really block your system. My record so far is a normal load of just over 1,400 for the 1 minute time, when it just like explodes. So, much better if you're going to do that to have worker nodes. Use Merlin, Modgib, for example, and maybe a Raspberry Pi, because why not? Just hand off that piece of work. So you have the concept is well understood, I think, that we all have a worker node physically. We just hand it off. He runs. He gives us the result back. My processor time in the middle, where it should be, doing valuable things. It's not really expensive, and you can get them delightfully rack-mounted now. Although I'm not quite sure why they have to number the slots 1 and 2. You could probably work it out. But so you can actually go the whole hog and have an appliance and rack mount them and just offload that work. I have had a customer who said, couldn't I spin up my own VMs to do that? And I'm quite happy to do that, but it is a kind of dependency on them. I quite like having control over the code and the hardware. Thruck. For those of you who haven't seen Thruck, here is Thruck doing a business process. Yes, it's sort of coloured and blocked and very attractive, but it's actually looking at live status to get the information. Now, live status, it can feed, Thruck can feed from upwards of 50 live statuses, so it can have 50 nodes feeding it at the same time. It's pretty. It lets you define this to say that what's a minimum of a requirement. So here we're saying this is actually in a warning state, although we've got a couple of red boxes, but that's okay because, for example, we've got a load balancer with 4 web servers underneath it, only one's broken. That's a warning, it's not a problem. Same for the database. One of the database instances is down, but that's okay. We've got another one, so that's a warning. So, and that starts to build a picture. Now that, in my experience, has been what customers, end users want to see. They have an application, whatever it may be, selling used car parts or selling points on credit cards. And all they care about is they have a set of applications that make it happen. And that's all they want to know. They don't care too much about the backups. They don't care too much about printing not working. They have a vertical that says these things are very important. And that's what they want reported, and that's what that shows them. Dashboards, well, I said there'd be dashboards. This is Thruck doing a dashboard and running mod Gibbon as it happens. But that's the sort of thing. Now, all that stuff sort of slides around the screen and you can move it around and you can change from pie charts to stacked graphs or whatever and get information. You can give this to the end user to drag and drop if you want, or you might want to build in something that you can't touch. I don't really care. But it's all there. And in fact, you can write your own widget to fit inside one of those frames. One of the more favorite ones, to be honest, is a Nagios one, so you can actually do the whole map of the world or whatever with the things going red and green so that they can work it out. Now, if they can't actually work out that some of their sites are on fire, I'm not sure I should be working with them. So overall, this is just a complete build of how to support multi-tenant. So each of these individual customers, they've got their own privacy, security rules, they've got their own data sets, they've got their own criteria in terms of SLA, and that's all kept separate, it's all kept secure. It all goes back to a central place where a support team can watch over it, I think is probably a better word, and respond if necessary. It's clustered, it's survivable, it's replicated, it's backed up, and it works. You can ask the question now if you want, as to how much it cost.
This is your golden opportunity to ask some questions. Is that a stretch or is that a question? Just had to get some clarification there.
Certainly.
This looks like a spirited group, you know. We're all listening so intently. Dave, do you explain things that well? That must be what it is.
No, they're all unconscious.
Not one question from this big group? All right here. We'll get to you next.
I had a quick question. So at your customer site, you have some possibly Raspberry Pis running Core.
Yep.
And you said you have these feeding back to Central via an open VPN or IPsec link.
Yes.
That's correct?
Yep.
So on your Central side, I assume you're running some kind of database to store the results of these things.
That's the delight of live status. So live status, which is running on the central core, is just eating that data from all those different places. Because we've got the naming convention, that tells us it's which customer it is and which customer location. It all shows up effectively in the same Nagios Core instance. And that's it. It's really simple. It really is very simple. And then you restrict your access. If a response team wants to look at a particular bank user, bank customer, then they just say, I'm only interested in host group bank or service group bank. And that's all they ever see, because it uses the contacts structure inside Nagios as it's meant to be used. And to be honest with you, it's one of the reasons we're using live status Thruck, because there were some, up until about 4.03, 4.04, there were some bugs in Nagios Core host group handling. It didn't work as convincingly as you might think. And live status and Thruck did.
Okay, so I got to know, what's the cost on the rack?
£1 sterling, $1.50 US. It's amazing what you can do with equipment in a skip, isn't it?
How many checks Raspberry can handle?
It really depends. If you're running plugins that are C compiled, then you can get away with between 450, 500 checks in a 5-minute period. If you run the more complicated Perl, PHP, you've dropped into Bash, then it drops down to about half that. But you can do all the things that you're supposed to do in the coaching manuals about, let's make it faster, let's have a RAM disk. Oh yes, we can do that. So you can actually tweak it to make things go faster. Let's keep Perl completely memory resistant. Oh, we can do that. So there's lots of things, when you know which problem you're hitting, there's lots of tuning you can do to make it happen inside a Raspberry Pi. But that's about the benchmark at the moment.
You mentioned you use OpenVPN.
Yeah.
What do you do to keep the tunnels alive?
Would you believe I send a heartbeat? It's a ping. And he keeps it up. We also have, if you're interested, I've got a couple of plugins that run at each end, because it's quite handy sometimes when you come through an OpenVPN to know the IP address at the far end, because it's allocated at the time of connection. So I've got plugins at each end that say, am I up or down? If I go up, and I've also got a plugin that says, this guy has IP address 10 whatever, because so I can sneak out if I need to.
You mentioned you use CheckMK live status, or MK live status. Did you look into CheckMK passive monitoring as well?
I did. I'll tell you, it's because of a particular route I took. And the route I took was I had something working with NDO, but it was appallingly slow, and the database, as you know, just fills up with rubbish. So I was looking at it from the terms of what can I do to make logging more efficient, quicker, and log reviews faster. So I came up the route just to live status, rather than going down the other side using CheckMK. It was just simply that. I'm still looking at CheckMK, but we're undergoing sort of a redesign at the moment. But as I say, it just so happened that I was coming up from the log basis rather than coming down from multi-site CheckMK type work.
Anybody else? How about a nice round of applause for Dave Williams?
Thank you.
Thanks, guys.